All right, so these are going to be three examples where I use the chain rule, finding the derivative of the following. So we're on section 2.4. This is just three examples I'll demonstrate, and then I'll do some more videos with more examples using chain rule. So from the last video, anything that has the structure u to the n power, where u is a function of x, is equal to the normal power rule, where we do the n times u to the n minus 1. So that's what we're used to. It's just the added thing that now I'm multiplying it by u prime. All right, this is u prime is the derivative of u. U is considered the outside function, u is considered the inside function, and the outside function is dealing with the operation of an exponent. And so this is referred to as the general power rule. And it's really just the chain rule. So I think of the operation as raising something to some exponent. That's what I think of the outside function. And then whatever's inside the parentheses in this case, if I had u to the n, so u would be the inside function. And then chain rule is derivative of the outside function times derivative of the inside function. But specifically for this case, we're talking about the general power rule that I'm going to apply to this problem, or these problems. All right, so number 10. So if I were going to find the derivative of this, note that you pretty much can factor the 5 out and then focus on finding the derivative of 2 minus x cubed to the 4th power. And so my u in this case is what's in parentheses. So this is going to be u. And then I'll just write the general power rule right here. So all right, so I have u is 2 minus x cubed. So if I were to find the derivative of u prime, so the derivative of 2 is 0 since that's a constant, and then taking the derivative of x cubed, so it'd be minus and then 3x to the 3 minus 1, which would be minus 3x squared is what u prime is. All right, so working out the problem. So if I take the derivative of y prime is going to equal, and then I factor out the 5. So I put 5, and then I'll put in parentheses this portion. So in this case, our outside function is raising something to the 4th power. So if I were to find the derivative of that, that means it's going to become 4 times whatever our function is for the inside function raised to the 4 minus 1 power. And u in this case is the 2 minus x cubed. All right, so this would be like n times u to the n minus 1 part of the formula for the general power rule. And then I multiply it by u prime. Well, u prime is the derivative of u, which is negative 3x squared. right? And 5 is being multiplied to all of this. So it's a matter of simplifying it. So we would have 5 times 4 times negative 3x squared. So if I do 5 times 4 is 20. 20 times negative 3 is negative 60. So it'd be negative 60. And I would put the x squared first, and then do the 2 minus x cubed. And then 4 minus 1, that's to the third power. And then that's going to be the result. You would leave it like this. You wouldn't expand it. So I would leave it like this and not expand it out. I mean, you could expand it, it's just more work than what's required. So leave as is, don't expand out. Meaning that you could do 2 minus x cubed to the third power. That's 2 minus x cubed multiplied to itself 3 times. And it's just a bunch of algebra to rewrite the same answer. Okay, so what happened was I applied this general power rule. I'm letting u be the 2 minus x cubed part. So I kind of ignored the 5 and factored that out, and then focused on the derivative of the 2 minus x cubed to the fourth power. So I dropped down the 4, so it'll be 4 times 2 minus x cubed to the 4 minus 1. That is the first part, n times u to the n minus 1. That's considered our derivative of the outside function. The inside function is u, so that'd be times u prime. And I found u prime is negative 3x squared, so that's why it's times negative 3x squared right here. So that's going to be u prime. And then it's just a matter of simplifying it. So I did 5 times 4 is 20. 20 times negative 3 is negative 60. I put the x squared first, and then the 2 minus x cubed part last. And then it'll be to the third power, since that's 4 minus 1. Okay, so that's that problem, number 13. Okay, so the variable in this case is s, so it's h of s is equal to negative 2 times the square root of 5s squared plus 3. Our outside function is that I'm going to consider is taking the square root. And when we handled square roots in the previous section, we did the power rule. And we applied the power rule by writing square root as the quantity raised to the 1/2 power. So I'm going to first rewrite it. So it's raised to the 1/2 power. So that way I can apply the general power rule. So the negative 2, I'm going to sort of ignore that and focus on finding the derivative of the 5s squared plus 3 raised to the 1/2. So that's, you could factor out the negative 2 in front and then focus on finding the derivative of just this part. Now the 5s squared plus 3, that's what's in parentheses. That's what you're applying the square root to. So that's going to be the inside function is 5s squared plus 3. So that's what I'm going to let u be. All right, so then u prime, taking the derivative of this, so this would be 5 times 2s to the 2s, the 2 minus 1 power, which is just 2s. So it'd be 5 times 2s, and then plus 0 since 3 is a constant. So u prime 10s. All right, so if I were to find h prime, again, I'm just going to write the -2. And then in parentheses, I'll worry about finding the derivative of everything. So derivative of the outside function, so I'm doing this part now. I drop down the 1/2, so it'd be 1/2 times the quantity 5s squared plus 3 raised to the 1/2 minus 1. All right, and then times the inside part u prime, and that u prime is 10s, so it'd be times 10s. Okay, again, so this lines up. This part is what the first part is, n times u to the n minus 1. In this case, n is 1/2. So it'll be 1/2 times our function u, in this case, is 5s squared plus 3, raised to the 1/2 minus 1. And then this portion, 10s, is the derivative of u prime, which is our inside function derivative. All right, so from here, it's just a matter of simplifying. So I have -2 times 1/2. Well, -2 times 1/2 is -1. So I could go ahead and just cancel out the 2's since they're reciprocals. I still have this negative sign. All right, so I have this -1 times 5s squared plus 3 raised to the 1/2 minus 1, which is the -1/2 power. Now, because I have this 10s, I'm going to bring this part to the front with the negative sign. So it'd be -10s, and then times the 5s squared plus 3 raised to the -1/2. And then we don't want negative exponents, so I bring this to the denominator. It'd be -10s up top, and on the bottom it's 5s squared plus 3 raised to the +1/2. And I would accept this as an answer, so that's fine. You can go further and just write this 1/2 power. It's the same thing as taking the square root. So you could write it -10s divided by the square root of 5s squared plus 3. And that would be what the textbook would want. So this is the answer. This would be what the textbook wants. I'm also okay with this being the answer. Right, so that's number 13. Now the next problem is number 19. So notice you have a fraction, and when you have a fraction, you could use the quotient rule. I'm going to use the chain rule, show how you would do that. All right, so this is the problem, and like I said, note you could use the quotient rule since you have a fraction, but I'll show both methods so that way you can see what I'm talking about with that. So first I'll use the chain rule. And because of the s cubed minus 2 to the third power in the denominator, if I'm going to apply the general power rule, which is really the chain rule, so trying to apply that, I need to rewrite this, and I'm going to rewrite it so that the s cubed minus 2 is in a numerator portion, but it changes the exponent to -3. So it'll be this is the same thing as what we have in the as above. So that way I can apply the power rule, and note that u is the s cubed minus 2 part. So the derivative of u prime, so the derivative of s cubed, that becomes 3s to the 3 minus 1 power, which is 3 minus 1 is 2, so this will be 3s squared. And derivative of -2 is 0, so you can just ignore the 0 part, so really it's 3s squared is what u prime is. So I know I kind of verbally described what it was for the steps. Now at this stage, I'm hoping we can get to minimize the number of steps, crucial, and just focus on the crucial steps. All right, so g prime of s, I'm going to factor out the 6 and then take the derivative of the s cubed minus 2 to the -3rd power. Well, I dropped down the exponent because that's the power rule, general power rule, so it'd be -3. And then times s cubed minus 2. And then I subtract 1 from its exponent, so it'd be -3 minus 1. And now I multiply it by u prime. Well, u prime is 3s squared. All right, so now I'm just simplify it. So I could do 6 times -3, that's -18. And then -18 times 3 is -54. So I'm doing 6 times -3 and then times 3. That gives me -54. And then I'll put the s squared first and then put the other stuff. So the what's after that is going to be the s cubed minus 2 raised to the -4 power. All right, that's a negative exponent, so I want to make that a positive, so I put it to the denominator. So you have -54s squared up top, divided by s cubed minus 2 to the 4th. And that's going to be our answer. All right, that's using the chain rule. So you can use the quotient rule. So I'll go through it real quick with the quotient rule just to show that if you are not comfortable with the chain rule for this particular problem, you could still use the quotient rule. So I'm going to pause the video and write the quotient rule. All right, so I wrote it out, the quotient rule, and now that I think about it, you're still going to have to use the chain rule anyways for finding the derivative of b. So like for our top function 6, bottom function is this whole thing, s cubed minus 2 to the 3rd power. So derivative of 6, that's 0, so t prime is 0. Now our bottom function is this whole thing s cubed minus 2 to the third power. And what I'm saying is you still have to use the chain rule for this part, for derivative of b. So the derivative would be the general power rule, so I drop down the 3, so it'd be 3 times, so that my outside function is the act of cubing. So for the outside function derivative, it's going to be 3 times the quantity to the 3 minus 1. All right, that's derivative of the outside. Then I have to take the derivative of the inside function. The inside function is s cubed minus 2. So the derivative of s cubed is 3s squared. And then minus 2 goes away because that's 0. So the inside function is 3s squared. And you'll see that this is more work than necessary because I still had to use chain rule for the bottom function's derivative. So if I combine it, it'd be 9s squared and then s cubed minus 2 raised to the second power. So I'm going to stop it there because it's going to be messier anyway, so I still had to use the chain rule. So it's more work than necessary. So I'll just write what it would be when I find the initial part. And so g prime of s is the bottom function times the top function's derivative. The bottom function is s cubed minus 2 cubed. And then the top function's derivative is 0, so it'd be times 0. Then minus the top function, 6, times the derivative of the bottom function. That whole thing, 9s squared times s cubed minus 2 to the second power. All over the bottom function squared. The bottom function is this. And you'll see it'll give you the answer. It's just more work, right? So this is the bottom function, the top function's derivative, top function and bottom function derivative, and then this is the bottom squared. And then you could do some algebra and get to the answer. And the answer was g prime of s equal to negative 54s squared. All of that divided by s cubed minus 2 to the fourth power. So I'm just saying you could use the quotient rules technically since that's a fraction, but notice that even though I do the quotient rule, I still have to use the chain rule for the bottom function since it involves the general power rule, so it's some quantity raised to an exponent. So it's easier to do it the first way without having to do the quotient rule. Just rewrite it so that it's 6 times s cubed minus 2 to the negative third power. That way it's directly applying the chain rule and you get your answer. All right, so that's where I'll stop this video. Next video, I'll do some more examples.